Uh,
Okay, so this is Oklahoma's open source robotic, or sorry, open source hardware, Oklahoma sponsored user group. I think there's a spiel to give, but I don't have it on me. The long and short of it is that that Oklahoma has been, well, before the pandemic, was really good about helping us with resources and um, things. And now we're all virtual, but anyways, they're a really great group. So if you get a chance, support them how you can. I don't know if there's anything that's happening recently. I don't think there's anything we need to announce. But anyways, the talk today is going to be kind of like a just kind of a bowl session um, home automation and on IoT and machine learning with IoT. Some of the things, there's been some kind of interesting stuff that's happened recently with ARM and how they've actually released a what is it, CMCS 5. I had a sheet somewhere. There it is. Yeah, CMSIS 5. And the neat thing about that is that they have native support for neural network libraries for all of their chipsets. So what that means is that if you've got an embedded project, you can, with a lot of effort, you can use these libraries to run TensorFlow Lite. There's a TensorFlow as a light version of TensorFlow, which is a limited subset of functions. But you can actually run your models inside of a low resource device. So low resources means that your model size is like somewhere between 16 and 256 kilobytes. So teeny tiny models. But more importantly, it also means that you can start running, you can start looking at running other like linear regression models, like k-means clustering models, other kinds of modeling, and other kinds of things on these embedded devices. I have one project that's actually using linear regression for modeling sensor data. And it uses the fact that ARM, well, a little bit of back history. So what happens is ARM sells core technology. So what happens is that you've got a company like Nordic or TI or Microchip, and what they do is they license different cores, and then they can shove it into their hardware and they add it in as a feature. And normally they add in like their own special sauce. So like, for example, Nordic normally has a Bluetooth a Bluetooth stack on top of it, and Microchip bought up Atmel, and so they usually have a combination of Wi-Fi and 802.11, or and as well as 802.15.4 for different mesh and Wi-Fi capable chipsets. But what happens is that when they put the cores together, they'll do things like they'll throw in like floating point number, floating point support, and DSP support into the product, and it'll be like a one-line ad on their data sheet that never really gets supported. So there's a whole like everything from like the M4 chipsets and above actually have support for this. So when they opened up when they created this library, it means that all those processors that had this core support previously baked into it now have the ability to run TensorFlow Lite models natively on the hardware. You're still constrained based on memory and RAM on the device, but it means that it instead of having like a special purpose, like this thing was designed from the ground up to be machine learning capable, it means that you can start running models on miscellaneous stuff. So for example, so that's kind of cool. So the let's see, got a link. Yeah. So just for example, the Arduino Nano 33 is what a lot of people have been. There's a lot of support around currently. It's a normal Arduino. The main key feature though is that it has a NRF 52840 processor from Nordic. That adds in, and it's a 64 megahertz processor with a 1 megabyte of flash and 256K of SRAM. But more importantly, it actually has the floating point and DSP cores in it. So let me just throw one more link out here. So what you're getting is that there's like a whole bunch of like really simple projects you can do with just this device. And the neat thing is that because it's not specifically targeting at just machine learning, it's useful for a lot of other different things. So that's kind of neat. The other options that are out there right now. So the neat thing about this is that there's two things that it's kind of like there's one big caveat with all this is that it's really really limited. And also, most machine learning algorithms are not the world's most efficient algorithm. They're designed to be flexible, not efficient. Efficiency takes, usually a machine learning algorithm is happy with like 80% efficiency or accuracy in the predictions. There are specific algorithms that are more efficient than a neural network and or a machine learning approach. The difference is that normally those are hand tailored and tuned for their application. And the neat thing about this is that it's DSP core. You can use that, or you can do a more general purpose, less constrained model and use a neural network core, or or machine learning neural network TensorFlow type core system. The downside of doing all this is that you have to have a model. And the neat thing is that the model, and to do the model, you also have to have so there's the model and there's also the like tuning the model for your application. So you have to have data and you have to have a model to work against. So it's still pretty much a pretty laborious project. Let me share my screen really quick and I will show you what all this looks like. Okay. So I'm all right. I may have too many tabs. Okay. So we're just going to do a quick search for this project. And we'll just shove that in here. Find out where they talk about the code. Which is, yeah, so these are all using the Arduino IDE, so it's pretty easy to work with and use. And then we get into the core data portion of it, or the model. Yeah, then you get into the classification of your different. Yeah, so the classification portion of it. This was on. Do you have any questions while I'm fiddling around with it? Okay. I had all these tabs open up on my desktop downstairs, which doesn't help me up here. There it is. Okay. So this is the actual Git library. It's okay. Well, I'll share it after I finish this up. So the this is the person detection. The one I wanted to show off was the Hello World one, because that's the easiest to work with. So this one uses a just a screen, and it uses actually a noise added sinusoidal waveform to then learn the algorithm and then create a representation of it. And you can go through the whole example. It's quite interesting. But just kind of give an idea of what this thing looks like. There's a model. The model is essentially a chunk of 64-bit numbers, or actually these are 8-bit numbers in a 242,488 byte block that's just loaded in. And so the algorithm essentially runs this through a series of transforms to do the math and the calculations. So on the device, it's just going to be, it's kind of, think of it like it's like a chunk of it. It's basically a function that you just chunk your data through, and it'll run it through this giant matrix of numbers, and then it'll spit out an answer. And assuming that your model is correct, it'll spit out the right answer. But you can only have so large of a model, so there's a lot of limitations on the size of the model and what you can do with it. So there's a whole bunch of information on how to take your really large model and how to slim it down while still maintaining the feature sets that you want. And that's kind of the extent of how far I can go with this. But the things that are available, like just to play around with, so there's the Arduino module, which is pretty popular. And Adafruit actually has a couple modules as well if you want to get into this. So they've got, so some of these are baked in with some of their features, but a lot of these are Like this, the MV cam allows you to have direct CAC plugin with like Arduino. And then I'm going to briefly touch on the Google and the Intel options as well, because they've got some interesting products as well. The main things is that they've got these TensorFlow Lite microcontrollers that this one uses the ATCMD. So again, this one uses a microchip device, but again, it's just an ARM that has the DSP libraries available, and they just have ported it over through TensorFlow Lite, so you can actually use those libraries directly from your TensorFlow model, which you generated upstream with gobs of data. So that's pretty cool. So the other thing I wanted to talk about, and do you think we have questions before I jump into the next part? Okay. So the other thing is, the other overview is that Google has come up with a really nice TPU unit for tensor processing unit. These are specific hardware ASICs that are designed specifically to do one thing and one thing only, and that is to run TensorFlow models. These are good enough to augment a Raspberry Pi, which has in it itself a full like 4-core ARM with like 8 gigs of RAM, 4 to 8 gigs of RAM, and enough processing power to run loops around a tiny IoT embedded sensor. And on top of that, one of the TPU units, these TPU units can usually give you about like 1 to 2 TOPS per watt. That's tera operations per second per watt, which, yeah, so 2 TOPS per watt, or 4 TOPS per for int8, which is crazy. That's good enough to do real-time video. So this is where you get into, and the price for one of these, so where we're all coming down to is that IoT stuff is very cost sensitive. These models would be more useful in an application like either a drone or a stationary camera setup, where you're taking in data in real time, and you've got an embedded Linux distro, and you've got this plugged into one of the M2 slots on your embedded Linux distro board. And this allows you to do things. This allows you to offload your AI model into this device and be able to do real-time processing with it. And at $40, it's very cost-effective, as opposed to getting into the NVIDIA Tegra or or some of their Kepler T1 systems. It's also can scale, so you can actually, like, if you have enough M2 slots, you can just slot more of these in. So if you've got a 2 or 4 M2 slot board, you could slot in 4 of these things. And this thing, well, this particular one has like a dual edge TPU configuration. You could have up to, with a 4 slot system, you could have up to 8 TPUs running at 2 TOPS per chip, which is, it's not going to get you up to like a desktop GPU top of the line area, but it gets close. The massive caveat with this line of product, and just to give credit where it's due, Intel also has a similar system called the Movidius. And they're about compatible. The major difference is that the Intel Coral TPUs are a little bit more accessible, the Google Coral TPUs are a little bit more accessible. They're a little bit more they're more easier to integrate into your product at this moment. Intel hasn't quite done it as much legwork on making these integratable into their hardware directly, but they're looking um, at more server side desktop style integration for like camera configurations and for like server deployment. But the one downside to using some of these devices is that they don't allow you to do training on the module. The way they work is that they load the model into the system once, and then they run the model repeatedly. There is the option of generalizing the last output nodes and then running those output nodes on a general purpose processor like the NRF52 or another ARM-based processor. But there's not a way of doing real-time learning or model learning on the device, not quickly at least. And the reason being is that it takes maybe about a second or two for the new model to get loaded into the chip. So to do rapid real-time learning in this environment would mean that it'd take way too long to try a new model, see how it performed, and then try it again. It's just not fast enough to refresh the model each time. But after you've developed your model and your model has stabilized, it does do a great job with running a more extensive model more quickly. It does have the same limitation. It does have some similar limitations. TensorFlow Lite, because it's a Google framework, supports those devices directly. So that's the good thing. The only downside is that it does limit it again. It is a limit on how fast how big your model can be and what kind of feature, what type of network you can actually put on it. But again, it's got the same kind of limitation where, in all these cases, you have to have a large pool of data to build your model from, and you have to have a large compute resource to be able to compute your model in the first place. But once you get your model defined, and then you can take that model and you can slim it down to fit on to either an edge TPU or onto a IoT device. And again, it's kind of like the IoT device is really small, really general purpose, and the edge TPU is a little bit more resource intensive, but larger models, a little bit more fidelity, and then after that, there's a big leap between going into dedicated hardware for like a GPU or a dedicated piece of ASIC for machine learning. But the exciting thing is that all these things, the power requirements for IoT are usually under like a watt, usually in the like a micro or nanowatt range. And being able to do these models, run these models in like advantageous high power time frame. So like, for example, when you've got like a lot of power available, like because it's sunny outside or you're plugged in for a couple of minutes, means that you can actually do some of these models in resource and resource constrained environments. So that's the AI portion of my talk. Does anybody have any questions? So, okay.
Sorry, I had to drop off. I had a student panic. Anyway, so these VPUs are really just kind of like a light version of a GPU used for trained models at the edge versus heavy deep learning type thing, right?
Yeah, so it's basically running the models at the edge. So you can think of it like, so if you think about like, it's basically, the nice thing about them is that they're ASICs, so which means that they're dedicated hardware that's designed to run one application.
Yeah.
Um,
Like
and
Bitcoin
so,
miners.
pretty much, almost exactly. In fact, a lot of Bitcoin miner companies have jumped into this realm because it's basically just a general purpose math coprocessor that's specific for a particular application.
Yep. Yep.
So the engineering talent to go into Bitcoin mining is the same talent that goes into AI mining, which goes when actually there's going to be a really weird crossover where all these servers that are very used to having very clean environments. Have you ever looked at how they do Bitcoin mining? They literally shove hardware into a rack and stick half of it outside and half of it inside, which is the dirtiest server environment you'll ever see. And they're going to probably end up doing the same thing for AI at some point. We're almost there, we're not quite. But because there's so much benefit in having massive AI compute hardware with, I mean, if you get the price down, you get the quality, you get the rate up, and nobody really cares like how long the hardware lasts because you're literally burning it as fast as it can go. So that's probably coming in the next couple of years. So that'll be interesting. Anyways, the way to think about it is that these things are special purpose AI chipsets that Google, Intel, and other people have been chasing. And the main benefit is that they are low power compared to a general purpose GPU.
Yeah.
Cool. But again, the only downside is that they've got a fixed. Usually, the Coral ones, the Google Coral ones in particular, have they have to load the model out all at once. So the model takes like a couple seconds for it to push through to each of the individual cells. Because you can basically think of it as like a massive. It doesn't have the bus channeling to do fast model refreshes, which means that's not appropriate for doing inference learning. I think I'm using that word right. But it's great for running a model that's already known. And the fact that it runs at like a watt per 2 tops, tera operations per second, means that it blows almost every general purpose processor out of the water. But even in that case, watts is still a lot of power to be burning for a IoT device. So the fact that you've got even lower level stuff that's using existing hardware on top of your Nordic or your ARM processor means that you can run your model. And you can advantageously run your model when you have the power to do so. So in a lot of IoT environments, either you're plugged into like a wall, or you're solar powered, or you're plugged in whenever somebody like needs you. So like you're plugged in when you're like let's say you're a camera, for example. You plug in the camera, you've got the ability to run people detection, pet detection, things like that natively on the camera, and then you can reduce the amount of processing that has to go up to the cloud and then come back down again, which has huge benefits for network latency, for detection rate, and all that type of fun stuff. So the next part of the talk is talking about. So in the past, we've done a couple of projects involving Home Assistant and Home Assistant sensor integration. And it's really kind of neat because the Home Assistant model is essentially you take an off-the-shelf or ESP8266, which is an expressive-based chipset, which it looks kind of like this guy right here. Well, this guy right here. This is an expressive chipset. So it's basically just like it's a 32-bit microprocessor that's got a Bluetooth and/or Wi-Fi capability built into it. And then you put some general purpose firmware on top of it, and then you can control the kind of like an Arduino. You can control the usually using the Arduino IDE. You can add in like sensors. You can add in like temperature, humidity, pressure, light sensing. You can add in like LED control or like lamps. You can do motor control. You can do a whole bunch of different things. But the thing though right now is that there's a couple of like proprietary systems that all have like their own special secret sauce, and they all do their own thing, and they're very proud of their hardware and they're very proud of the software. They all have fees associated with them. But there's also like a whole bunch of open source projects that have most of the same features, but they're just a little bit rough. So what we did, I think a couple months ago, I want to say, is we did this project, which is we took an ESP8266, and we took a temperature, pressure, humidity sensor, and we plugged it in, and we had it work with well, in this case, we just had it work with Arduino, but this same platform can work with a programming interface called ESP Home. And ESP Home lets you use a YAML configuration file to configure your sensor, and then allow it to push data to a MQTT database or MQTT system, which then can also be pushed in up to like some databases of your preference, essentially. So the neat thing about that is that you can do these things. You can use this thing for like monitoring your home house humidity levels. You can actually watch the temperature rise, and then you can watch your AC kick in, and then your humidity and your temperature will drop, and then and then over time it will slowly rise back up, and you'll basically see it stair step. So it'll go up, it'll stop, come back up, it'll stop, and it'll kind of stair step. And you can also do things like add in motion detection sensors to monitor where people are located. You can use Wi-Fi signaling to detect like where basically you can get presence on where people are at in the house, things like that. And there's a lot of really cool things that people are doing, kind of piecemeal here and there. One of the projects that I've been working on the side is integrating all this in with some open source plant managing systems, so that we can do a custom like weatherized and weather resistant sensors and hardware for grow and for plant management. So this would be useful for things like if you got really at this point, what it'd be useful for is like monitoring the humidity and temperature in terrariums and your plants, if you got like a home garden, something like that. And it also could be useful later on down the road for like large ag installations. So like greenhouse tomatoes, or what's probably where the biggest money is at this moment, the medical marijuana industry. But the neat thing is that keeping all the hardware and software open source means that there's no vendor lock-in, there's no issues with, if somebody goes out of business, it doesn't matter. All that data is still available. And it just really, what's missing in the market right now is a standards bearer, and a way of making it easy for a end user who doesn't really care about how it works underneath the hood to get support and talk to a human person when it doesn't work. So those are the two things that I'm primarily working on. But I guess any questions about that?
I guess, Lawrence, part of this, so are you planning to integrate all that continuing to use ESP Home as the software framework, and you're just making a productized set of sensors to do that? And so behind the scenes, you're establishing modules to leverage the data via that, or are you setting up a completely different framework?
Well, I'm slightly lazy, so as long as the licenses are permissive, then I'm probably going to keep on using it. The nice thing about the ESP home environment is that, so the nice thing about using open source as a design and business strategy is that it is a gateway to your own stuff. It is the equivalent of doing of Red Hat and having CentOS. So you'll have people who will cobble together their own hardware and shove it into your system and make it work. And when they go to deploy it across like a 100-acre installation, they want to buy prepackaged things with warranties. So that's where I want to be. But people are going to want to get started with the cheapest thing available. And at the late stage of the game, when China's or whoever's making the cheap stuff at that point in time have flooded the market, I want them to be invested in standards so that everything works and is compliant, and that there are standards and conferences and rules in place, and somebody has to basically be in that spot for managing and focusing on that, and that's where I see a market potential. So the idea is really also just to basically fill this gap, because there's a lot of really bad hardware out there right now, and it's not going to take a lot to be better than that. But at the same time, I don't want to be better just because you can be better. I want to be like better and progressive. So this also means I'll probably get put out of business at some point. If you look at the history of most open source projects, they tend to have to keep on moving iteratively on a regular basis, or they get outcompeted by a hardware manufacturer that just makes the same thing that they made cheaper, faster, better. But that's not a problem with me. That doesn't bother me either, because that just means that I've been very successful. So my goal is better hardware. So let me show you what we've got right now. So we've got it already integrated in with Home Assistant. I don't have it plugged in right now. But
has anybody else in the call started giving Home Assistant and much work in their homes, or because every time I see your projects, I see you're like completely start from scratch. So I didn't know if you did or not. I mean, you like build everything, from the ground up. I'd rather write a few lines of YAML and have ESP Home handle it. But by the way, Lawrence, I don't know if you saw the news in the past month, but ESP Home has been, I guess, acquired, by the folks with Home Assistant.
Yep.
So it's
yeah. So yes, and that's Home Assistant is slowly targeting them. This is one of the reasons why I'm a little nervous about Home Assistant. They don't quite know who they want to be yet. I mean, I'm hoping that the Home Assistant wants to be Debian, and I want to be Ubuntu. I want Home Assistant to be where like all the crazy shit happens, and I want to be like, I want to make the like a friendly front end facing for that. But I think that Home Assistant has so the poison apple in IoT right now is wanting to have the whole pie for yourself, and that means that everybody who, I mean, it happened with Google, it happened with a lot of other companies, but like the moment you're like for example, Google integration with their home assist or their home vision home automation stuff all got shut down at one point because I don't know, I'm not entirely sure the full reasoning for it, but it was pretty devastating. Okay, so let me share this really quick and I'll probably take more questions. Try this. Okay, I'm just going to share my whole screen. So this is basically just a React app, and it's pretty basic. It shows the It's just house. This is my house. Well, my house is on house 2. And we're good. So sorry, I guess to step back. Let me go back. So these are Daniel's slides. I'm working with Daniel Ashcraft. He's a web developer, a web app front-end, back-end developer that I've worked with in the past. So the sensor I was showing you previously is house 2. You can basically kind of see how temperature and humidity kind of line up. My downstairs is a lot more efficient than his single story, as you can tell, because my AC runs like once or twice a day and his is running all the time, it looks like. But it's kind of interesting. You can just you can basically map your entire temperature, humidity over a long period of time. You can use this information for monitoring your environmentals inside of your house and making decisions based on that. So I guess just to kind of overview, like right now the process is either you buy a pre-existing IoT sensor and you hook it up, or you build it from scratch. The scratch is nice. Building from scratch is nice because you get a lot of control, but it's not something that you want to basically get these things as cheap as possible. You want to make it as easy to reconfigure them as possible. And I think that's where the ESP Home comes in, because it's really easy to reconfigure those. You can also even reconfigure them over the air, which is really handy. And because it's an open standard, if you brick it, there's a process in place for recovering those. And so the whole idea is that like IoT needs to be cheap. The way a lot of business people look at IoT is that they want to basically raise the price to whatever the market will bear. Unfortunately, IoT is one of those industries where it has to be as cheap as possible, because what happens is that you get a network effect with IoT.
Or do the processor, and if not,
with IoT, you get you have to have it as cheap as possible to get it to the point where you have multiple devices working in aggregate to get you where you want to be. So that's one of the problems that the market's seeing right now, is that there's a lot of people selling really expensive IoT devices when really they need to be as cheap as possible. They need to be disposable, because you want these things everywhere.
Hey, Lawrence.
Yeah.
This is actually really cool. I just had another. I'm doing capstone this semester with my students, and they're all anyway. This is pretty cool, and I'm going to want to follow up with you because I'm a falconer and I have chambers for my birds. Yep. And monitoring the temperature, humidity, that kind of thing will be really cool. So. Yep. Could you drop your email in the chat? And I got to drop because I had to get another student ping me, and then I'll follow up with you.
Are you on Techlahoma?
I am not yet. I have to get on there.
Okay.
I am in the meetup, but
yeah, we're all on the Techlahoma DYI electronics group. But okay. Let me see if I can figure out. There's the chat button. I think I might have to stop presenting to chat. So let me do that.
You have to go to the very top. It's hard to find.
Oh, yeah, and you got to click the button. A lot of times it's the ... It hides it.
I'm going to send you an invite, Troy, so you can just click the link.
Yeah, that's me if you want to get a hold of me.
Okay.
I'm open for all sorts of collaboration and chats on whatever you want. I'll either, basically, as long as I don't get bored or it's not too much work, I'm pretty cheap. So pepper me with, I like questions, I like answers, or I like work on things. So
Thanks,
so anyways, so the whole idea is that they need to be as cheap as possible, and they need to be as accessible as possible, because these need to be throwaway to get the penetration to make them really useful.
So how are you going through the process if you're basing it on the 8266 and how are you powering it for a long period of time, especially if you're out in a place where plugins might be
So
solar
that's a very good question.
well, because
Um,
I mean,
Go ahead.
I mean, that's the thing I keep running into is like, if you want to keep it as cheap as possible and maintenance free, it's like, I keep thinking that other people have already tackled some of this stuff better. Like these guys that I was trying to get Yuri to explore for his trash can thing, right? You know, it's like you knock out multiple opportunities, right? You know, it's got Bluetooth that lasts a year on coin cell. You can track use the RSSI to figure out, proximity to some degree. And, you get the temperature and humidity, those types of things. And so it's like, when it's $2 a pop for this and you throw a coin cell and a battery in it once a year versus other options. I just haven't seen anything. That's the thing. It's like,
well, that's where it gets interesting. And that's the I didn't view of that. Is that the ESP8266 based temperature?
no, it's not ESP8266 based, but this is that Chinese product, and people have open sourced the firmware, so you can just go in and Bluetooth send your own firmware to it and have it automatically do some of the calculations. Like if you only cared about a differential over a period of time of a certain amount, otherwise only send a report every 10 minutes, right? So you even extend the battery even more.
Yeah.
So, I mean,
So yes, and what I would say is that there's two problems. One is availability. The moment that product gets discontinued, or the moment that company decides that they want to close source their version, then that goes away. So having a implementation that is open source and that I've got control over and that I have.
oh no, I agree. I'm just wondering, how do you get to that price point where it's not simpler to have, a hybrid set of IoT devices, right? They could easily have this set and plug in and play once
That's the beautiful part about all this. I don't have to own the hardware. I don't have to support all the hardware. I just have to have a platform that people can plug into. The thing that makes that thing useful is that is about 5 minutes of professional engineering support saying that this product will work with this environment, and here's the configuration file. If I can provide that value add on top of a pay-for system, then I can pay for the engineering time to basically maintain the framework to make that easily adaptable. And I can both pay it forward by having it available for anybody, push it back into the ESP home platform, so we maintain parity of feature sets, and then also because the people, for 95% of the people that are ever going to use this type of system are either going to be people who buy the cheapest thing available, or people who want something that's known to work. The people that and those are great, because those will have value add into the system long term. The way you make it pay for itself is that if you buy a product through a company that has support, then you get direct support from that manufacturer for that product. If that product that you have in your hand doesn't work, you don't have any recourse. You can probably send it back to Amazon and they'll have to deal with it eventually. But there's no like, this doesn't work with my system here, who do I talk to? You're basically up to you and the community to figure out how to make it work, which is fine for hobbyists, for people that are doing things here and there, but for large installs and people that want that reliability, it's not acceptable.
Yeah, I got you. I guess I didn't pick up on your target.
My target is everyone, but the tricky part is figuring out how to make it work for everyone too. But to answer your other question of how do you make that sensor work reliably over long distances where you don't have infrastructure, the only answer I have right now is solar. And the only answer I have on top of that is solar plus a really low power charge strategy or messaging strategy. So the idea is basically to have like a single, and it ups the price, but I believe you can still get it under the $20 range with off-the-shelf solar, with a off-the-shelf battery pack, and with a low-cost radio transmitter.
I will say, in case you're interested, I don't know if you follow the guy with the Swiss accent, but he started a while back a Discord channel called Superpower, where they're focused on super low power custom open source boards for powering either ESPs or Raspberry Pis, depending on which project. So there's two different parallel community development efforts to design based on the lowest cost chipsets for charging and operating with the lowest quiescent current needs. So it's pretty interesting. I don't know where I haven't gone back in. I'm on that Discord. I tune in occasionally, but they've been making some progress, but getting to the point where, you know, there'll be some good open source designs to be able to do a combination of battery solar support and keep an ESP, you know, able to do some level of sensor measurements. And anyway, I didn't know if you were aware of that project.
No, but I think I need to go jump into that because I've got a couple of ideas on how to do that circuit. It'd be good to see what else people are working on right now. And the intention of all this is to keep it open source. So like I don't think that's gonna be a problem. Which is also the only other reason I like talking about it on this channel. Otherwise, I wouldn't talk about a closed source hardware design on a open source. That's just me.
Better not. I can
I'll figure myself out. But anyways, the whole point is that like we can, I think with low cost sensors or chipsets, you can get the cost very reasonable. And again, like we're using the product that I was showing previously was using the BME 2800 or 280. It's pretty pricey, but mostly it's like in the $2 to $6 range. But it has a lot of feature sets in it. So pretty cool. And this is just kind of going over like there's a lot of different projects that already use this. But again, it's like, that's one of the reasons why they're so cheap in the first place, is that there's like a lot of people that are already doing this. There's a lot of examples of it. It's a pretty popular project too. So that was the estimated cost for one of those devices hardened. The way I was going to get that price was essentially by doing injection molding and doing a soft body housing for it. So what that would look like is that would be a soft body or a rigid body impact frame, and then an injection molded TPU or similar soft body elastomer to protect against environmentals. But then in this particular case, all the power is being provided by a 5-volt external power supply, so there's always that cost as well. For the solar power option, the price would be more, and it would be a kind of a brick in that case. They'd have to make sure that it is pointed to the sky. And just going over the programming, it's a YAML file, so it's pretty interesting. Like the YAML profile is actually based off of the home automation, the Home Assistant YAML platform. So it's actually all, and the Home we've had some previous talks about Home Assistant itself. But Home Assistant is a really interesting platform because it basically works as a hub for other web API enabled dashboards that could be anything from like your camera setup to temperatures to your home gardening setup, or if you're doing falconry, for example, something like that. You can actually have like a special dashboard that's got all the user interface configurations just for that. So it's really kind of interesting. But it's just basically a plain text YAML file. we're going to end up having these indexed and pre-configured per user. And there's a whole bunch of infrastructure in the back end to make that seamless. So the main one that we're trying to target is this ease of use problem. Right now, it's doable. There's a lot of documentation, but you kind of have to have a bit of a hankering for IoT to make it really functional. But what we want to basically get it is we want to get it to the point where it's circumstantially beneficial. So you don't notice that it's useful until you need something, and then you realize how useful it is. The best example of this is that right now we've got a full distribution of Bluetooth through a lot of different devices, through speakers, through your phone, through your car, through your computer. And you can do things at this point like say, hey Google, you can tell Google, I want to play in the Den speaker, and it will start playing music from your Den speaker. And that kind of like that seamless, thoughtless, I need this to happen, how do I make it happen interaction is where you basically get your user interface seamlessly, transparently working for you. If you have to think about it too hard, then you've already lost. So yeah, so there's a lot of, so the neat thing is that once you start getting data in, there's a lot of options for data ingress. And then it's all the sky's the limits for machine learning, data acquisition, modeling, future prediction, stuff like that. So there's a whole bunch of really cool stuff you can do once you start getting a massive amount of data in. And then forming that into various projects is where it gets even more interesting. So I mean, I guess right now we're at the MQTT level and at the node microservice level for, and then basically acting as a middleman. There's a couple of our farm specific applications that are designed for monitoring calendars and for monitoring different grow conditions, which we're looking at integrating in. I'd rather not make our own basically a farm interface. I just want to basically be I just really want to be a middle layer between like the sensors and the pre-existing software stacks. But if it doesn't exist, we may have to create it though too. But there's a lot of, I mean, farming is a crazy industry. There's everything from like inventory to like individual status of either herds or plants or animals or crops or beds or things like that. And then there's how do you relate those different pieces to different parts of the business and or just hobby, and how do you make it seamless and easy to use. So that's the end of that talk. Does anybody have any questions? Okay. So that's I guess that's the nuts and bolts of machine learning and Home Assistant and plus temperature sensors plus middle layer development. So I think I've been talking for 2 hours. Or actually, sorry, it's only been an hour. My clock over here is wrong. So anybody else have any questions, projects, things that they've been working on?
I want to know if Yuri's trash detector worked.
It worked kind of. So problem is those are facing sun, and sun has huge interference with IR sensor.
Mm-hmm.
So that's the only problem. When I tested, there was no sun, so it was fine. It was fine. it was fine without sun. So I'm currently trying to find different approach, right? Really short radio, so I can control distance.
Mhm.
That's pretty much what I'm looking for at this moment. So but
What kind of IR were you using? Were you using the like the NEC encoded IR,
no.
or were you using like straight, or were you just using something else?
So it's IR sensor. So it's supposed to respond only on a trigger only on one frequency. I think it's 38 hertz.
Yep.
And that's what my generator was producing, but it's still, I tried to be precise on frequency and it wasn't apparently a problem. Problem was just sun interference. So I have just device waking up too often. So if it makes sense.
Like an easy one there.
So I'm not willing to set up any shades or anything else to protect those at this moment.
Yeah, I would say that the only, because what happens is the sun acts as a broad spectrum interference source or a light source, and it will overpower any of the sensors that you have currently.
Right.
So your two options there is to make a shade for it, and then put in a notch filter. They make near infrared or infrared notch filter films that will basically block the light only for the very narrow band that you currently have. Think of it like polarized shades. That can help, but the main thing that you can do is add in a just literally like a little sun visor shade for it. That may help.
Right. Yeah, but then I was thinking if I'll build a receiver. So basically, I just need build RFID. Basically, just produce powerful enough signal to wake up radio on the other side. It might be more simple solution than notch filter.
You can also use a like a Bluetooth and or like a Bluetooth beacon. And what you can do with the beacon is that you can like if the beacon is too powerful, you can actually, depending on which beacon you use, you can either like in software change the attenuated power on the antenna, or if you are feeling brave, you can go in there with an X-Acto knife and detune the antenna. Will also shorten your
Yeah. Oh, yeah. So I'm looking for passive sensors. So, and all of those solutions, it's kind of, they will just waste power.
Mm-hmm.
Yeah, it's kind of that same issue James raised. It just does not make sense charge batteries.
And that's why I got like a plan to do this. I've already got one because that's how I scan the sensors right now, is with the ESP32 running the BLE through ESP Home. But I'm thinking about just putting 3 or 4 more ESP32s, like one in the garage, one in the, and then that first link I sent, somebody else did this similarly, where they just took all the readings of the RSSI levels of all 3 or 4 of those devices, and then basically built a model so that it can estimate what room you're in. And I was thinking, if I've got one in the garage, then I could estimate whether or not the trash can was sitting. So it's still going to consume power for the ones that are in the house, but the sensor, one of these, will last a year. And the added bonus is I know what the temperature is outside in a shaded entity. Well, underneath the lip of the trash can,
right.
And in that way, do a little bit of designing of the model to feed in all the locations. I really like the cat write-up. I don't know if you'd seen that one, but basically just it took his cat and threw eye beacon on his car.
Right. Yeah, I saw that one. Yeah.
So that's what I want to do. I just haven't gotten the energy, and that's that. But then the cool thing is it serves multiple purposes, right? All of a sudden, then your smartwatch serves as a beacon, and you can start doing things that are room specific in your house, right?
Yeah.
It's not just tracking the trash can; it's also tracking.
Yeah, I was planning to extend that to mailbox and garage door, all those stuff, but
I
trash
mean,
can was just
Start.
something with distance.
And it's
think
the one that
solar-
causes the most headaches, right?
Yeah. I think you might want to look at solar, to be honest. Solar is really probably going to be your easiest way to get long-term survivability. And on top of that, I need to go look at this. I got too many cats. Sorry. But if you look at the solar installation and then maybe like a charging circuit for like either lithium or like a super cap, then I think those might be options for, because you only need to send out data like once every minute or two,
Mhm.
or less or more. So that you can basically do like long-term sensor data generation wirelessly with solar.
Yeah, that's what I noticed. It's not a problem of waking up once in 2 minutes and send some signal. It's not consuming that much power.
Yeah.
Hey, you're like a little bit of a programmer, I know.
Yeah.
So there's one data source that a bunch of us about a year ago got frustrated with the city of Oklahoma City. They have an API, but they've got it behind a I guess inappropriate use filter or firewall. So like it has some weird mix of limits. Like so even if you only asked for the API call once every day, it would trigger. But then if you did it from your web browser, you can spam it all day, and it whatever different elements it's checking for, if you don't trigger it. But basically the API call, and I can give it to you, gives you the timings till the next big trash, to the next recycle, and to the next just regular trash days. And so I have a Node-RED workflow where it all works if the API isn't blocked temporarily, and I can't.
Yeah, that was my next step, to find that API. Worst case, I was planning to go with website Oklahoma City has.
Yeah,
I can
I've got
look
the
at.
API call from then, but I just haven't been able to figure out how to make it clean. You know, if you do it through web browser, you can ask all day and get the JSON elements, no problem. But if you do it once a week via just a curl, it fails. It's just I don't get it.
Yeah, I can look. Just send some info on the channel. But again, if somebody listening, they might think if we will came up with something smart, they will
Hey, have
find
you
way.
thought of impersonating your agent string?
What's that?
Thought of impersonating your agent string?
I've done that. I've
doesn't-
done all sorts of stuff.
Have you tried just trying to use and it's more heavy lifting, but have you looked at Selenium? It's meant for
Yeah,
testing
I don't want
UIs.
to. I mean,
okay.
it's at that point it becomes BS, right?
No, I know. I just meant that you could tell Selenium to grab it for you. I mean, it would suck, but it might work that way as well.
They might have they're using cookies and some maintaining session. That's
This isn't my address. I changed the record ID, but that's the API call. And the developers at the city said, oh, just pass my param of anything different each time, and that will work. And that's BS as well, because I put in like the second since the epic. So like once a week I'd query it, but that's the call. It saves you a lot of trouble. If you go through and just do your own lookup, you can get your record ID for your house. I feel bad I'm picking on somebody on Condor Drive, but that's not me, and don't pick on whoever that is, but that's it. So the idea would be, and I have the workflow, so it will automatically set off, the lamps that we built as part of the open source hardware. I had it all worked out, and for one time it works and it lights it up, I was having it so it lights up more and more as it gets closer to big trash day or recycle day, you know?
Yeah, that's what I was thinking. It was my backup plan. If that experiment will not work out, I'll just do software.
Well, I would, Yuri, you would be one of my favorite, myself and Adam Collins and a couple other people got frustrated. And I've got a couple of Node-RED workflows that you're welcome to that are pretty, you know, we all about a year ago just went through this and just had a great time. Of course, watch me say this and now they finally got it off of that automatic filter, but it's just so frustrating because it could have all just come together and we would have these really robust ways of not forgetting recycle day or, oh, it just makes me angry. Yeah, I mean, in fact, if you look at my Node-RED setup, I've got like 8 different workflows or flows that I was playing with, just trying to get it to work. And a couple of them, I say really bad things about the city. I mean, so the namings of some of the cells are not appropriate for, you know, mixed company. And I've got a chain of emails with the city where they're like, oh yeah, just pass this different perimeter and that should work for you. And I'm like, no. And David, I appreciate the Selenium idea, but when everything,
no, I know it's a
perfect,
pain
I'm
in the
like,
ass. I know, it just meant you could completely impersonate it, but
yeah.
Yeah, eventually I was planning just to add something in Home Assistant.
Yeah, that's what I have. It's in my Home Assistant all ready to go. If I could just get that query to not fail.
All right, I can look at it.
And I'll say Adam did a really cool workflow in Node-RED where he actually has both the big trash alert. So he has a colored lights in his utility room, and he had it set up so that at night his light would turn to a certain color if it was a big trash day or if it was a recycle day.
So it's not only me.
Yeah, not only you. You're not alone. But hey, hopefully this API call helps you out. Just if you go straight to what's my big trash day, you can find out your record ID by looking at the source code for the page. And then he was doing it based on geography. Like he actually, there's another API call you can do where you can just pass your general neighborhood and just count on the record to come back. But that particular API call is kind of neat. It gives you a bunch of other information depending on which calls you make. So it's like the city tries, but they fall short of being awesome because they've got some really cool, in case others on the call are interested in it. They've got a number of interesting things that they make available through the API, but at the end of the day, they put it behind some sort of web app firewall that is too aggressive. It's like you can spam it all day from a browser, but if you ask more than once a month via the API call, anyway, frustrating.
I see.
By the way, these temperature sensors I've verified, they work great in freezers for a long time. I've got one of my Grafana pages. I was double checking. I hadn't looked at it in a while. In case anybody's interested here.
So do you think you're ready for like a group buy of those temperature sensors then?
I've bought a couple of packs and I've given a couple away, but it's like this is my not in the house or not regular room sensors, just because I wanted to see the extremes. Let me see, I'll share it real quick.
Because I mean, it sounds like you could almost do like a full house.
Yeah, so this particular graph is just showing the ones that are in the freezers or the fridge or out in the garage, the hot water tank closet. So you can see like when the garage temperature, oops. Oh, good.
Here, you came back.
just briefly.
Did I lose y'all? Well, it told me Zoom and I can't stop share.
Be mine. Thanks.
Anyway, I don't know if you were able to see it, but it's fun to play with. Those sensors, not bad for a $2, $3 sensor you throw in a freezer and it just works.
Yeah, they're a little bit more expensive if you try to buy them off of Amazon, and they're a lot. I think you have to buy it. I had to go. When was the last time you purchased them? About
a month ago, I went on AliExpress and bought 4 4 for 14. So I guess it's a little bit more.
Okay, so yeah, it's about $4 a piece. Not bad though. Yeah, I mean, I bet it's one of those things where the more you buy, the cheaper they get. So if we can get them in like if we can get them at like $2 to $3 a piece, that'd be pretty nice. So that means you could do like you could do almost every room in your house for like less than $100, or significantly less than $100 if assuming you have a reasonably sized house.
Yeah.
Which then you get to do fun things like you can find out exactly which air vent in your house needs to be readjusted. Because you don't, when you run the AC, you may have like hot spots in your house versus other parts of your house.
Yeah, I got these originally because my wife's impression of what the temperatures ought to be in a room and my were, it's like it was getting the thermostat cranked down to like 68 degrees to cool because I thought the living room was too hot. And sure enough, there was a pretty big differential between the living room and where the thermostat was. And so I've got a different graph that shows the 5 or 6 that I've got distributed that aren't in freezers, fridges, or hot water tanks. So I can see them where they, would hopefully they all align within a bit. But I don't know if you've noticed this, but the temperature on the BME or the BMP is not super accurate.
Yeah, that doesn't. Well, that's because it's a most of them are like what call them? It's a thermistor as opposed to a thermopile sensor. And so the thermistors are resistive elements. And so depending on the temperature swing that you're dealing with, they can be less accurate over a particular range of whatever you calibrate it for. So there's internal calibration factors that can vary. Also, depending on how the particular sensor you have has what kind of chips they used, what kind of resistors, capacitors they use, those can all influence as well.
Yeah.
So my guess is that when you buy them cheap, they just use whatever they have available. So there's a good chance that they may have messed one of those things up. But as a cheap throwaway sensor, they're great. Or as a cheap sensor that's integrates then 3 different temperature readings, they're fine. So if you want more accurate, a thermocouple is much more accurate. So
be interested to hear more of how your design works out.
with the temperature sensor?
Yeah.
Yeah. Well, right now I'm just going to copy the existing 8266. I may upgrade the processor to one of the Expressive's more recent ones. The 8266 actually is more expensive at this point than the ESP32 because I think they're trying to shuffle those out and they're trying to move over to a different chip core. We showed it last week or a couple weeks before, but the ESP32C3 based on the RISC-V platform, I think is going to be the next low-cost platform. Because they actually released the C6 recently, or the specs for the C6. And the C6 is basically a beefed up ESP32C3 with faster Wi-Fi and I think more features. So I'm going to basically, my plan is basically to get the size down to like back down to this size, and then add in the BME sensor directly onto the board, and may or may not. And also, these things I believe have the no. Okay, so these don't have the. I thought one of the versions of the ESP32 have the USB built into the core, but I don't think this is the one that doesn't. So I want to basically have like as much of the peripherals built into the core as possible, so I can only do a 1-chip solution. But I need to basically do I'm basically trying to get the software written first before I do a board design. But when I get that going, I'll definitely show that around. I also got to figure out how to weatherize the thing so that it can be dumped into the dirt for like 6 months and then brushed off and still work. So that's a whole other set of problems. So, but yeah, I'll definitely let you know. I'll let everybody else know. So, I think I gotta run actually, because I've got a lot of things going on. Anybody else have anything else they want to talk about or share, or projects they've been working on, or questions that they've got? So, okay, well, James, can we, if you got the recorded file,